35.3, we'll be isolating terms in formulas. Okay, on our first one here, we want to isolate for a here. So we have a squared, a minus b squared, and a plus c squared. Okay, first we're going to get rid of the these two adding and subtracting terms, and we'll be left with the a squared term. Next, we'll get rid of the square, and then the a will be isolated. So let's start that process. Okay, we have a squared minus b squared plus c squared equals d squared. Okay, we're going to get rid of these two terms right here, the minus b squared and plus c squared, by using their additive inverses. That means the opposites. So we're going to use a plus b squared here and a minus c squared there. And these will cancel. Whatever you do to one side, you do to the other. So plus b squared and a minus c squared. What's left on the left side is only a squared. Whereas on the right side, we have the b squared, we have the d squared, the b squared, and the negative c squared. So let's put all those next to each other. D squared, the positive b squared, and the negative c squared. Now from here, we want to get rid of the square from the a. So I'm going to write all this a second time here so you can kind of see the process. We're going to get rid of the square by taking the square root of both sides. Okay. And you notice I don't take the square root individually of the entire process. So it means all this has to be done first, and then the root is going to be taken of whatever's left after these are all simplified into one number. That's why we don't start taking the square root of everybody individually, because this process says find all of this and make it one number first, and then take the square root of that one number. So this will be a, and this remains the square root of d squared plus b squared minus c squared. Okay, on the next one, we're looking for a again, and we have an a cubed, a minus b cubed, and minus c cubed. That'll equal d. Okay, to get the a by itself, we need to remove the minus b cubed and the c cubed. So we'll remove both of those. Oh, ignore that. And once those two are removed, then we'll remove the cube next, and we'll get a. So this will be our path to getting a by itself. So let's start off by writing the problem again. And let's see, we have a squared, a cubed, minus b cubed, minus c cubed equals d. And we're going to move these two right here to the other side. And I'm going to use the additive inverses, which is the plus b cubed and plus c cubed. Those are the additive inverses, and they'll cancel out those. And whatever you do on one side, we'll also do another side. So plus b cubed and a plus c cubed. This will leave our a cubed for the left side, and on the right side we'll have our d, we'll have our b cubed and our plus c cubed. So d plus b cubed and plus our c cubed. Okay, next I'm going to write this again, because the next step is to get rid of the cube from the a. Now I want to point out something earlier. Typically, when we take the square root of both sides, one side it's a plus or minus. The only reason why I didn't put a plus or minus here is because all terms here are assumed to be positive, so the a would be assumed to only be positive, so we wouldn't need the plus or negative, since we'll only end up using the plus. Now, with cube roots, and that's what we're going to use to get rid of the third power here, I'll show you the cube root looks like this. It's a little 3 in there. What you do on one side, you do on the other side. With the cube roots, we don't use plus or minus because it could be, if this side is positive, that side will be positive. If this side is negative, that side will be negative. Same thing, so it'll match. So we don't have the plus or minus issue here. So we don't need plus or minus. We can just say A equals the cube root of D plus B cubed plus C cubed. And that solves for A. Okay, lastly, I'm going to write the problem down first, and then we'll see what parts we need to get rid of. We have the cube root of A squared plus the B squared plus the C squared, and that all equals D. Okay, so we're going after the C. No, sorry, we're going after C right here. So who needs to leave first? What we'll do is that we're going to get rid of the root first. Again, we have a root over everything. So everything's contained in the root. So we get rid of the root first. Once the root is gone, still solving for C squared, we can get rid of the A squared and the B squared, and that'll leave our C squared. And then finally, we can get rid of the square on the C, and then we'll have C isolated. So that's our goal. Let's put this up here. All right, so the cube root of this expression, A squared minus B squared plus C squared equals D. The way to get rid of a cubic root is to use a cube. So I get a cube. So I'll put all of this to the third power. And this third power will get rid of the root here, and all of that will go away. What you do to one side, you do to the other. So we'll put a third power there as well. And what we'll get is the root will go away, and we'll be left with A squared minus B squared plus our C squared. And D, all raised to the third power, is D to the third power. Okay, next, we'll get rid of the A squared term and the B squared term. So I'm going to subtract A squared, that's the additive inverse, minus B squared, that's the additive inverse. And when we do to one side, you do to the other. So the negative A squared and negative B squared also go over there. And we'll be left with, on the left side, just the C squared. On the other side, we'll have the B cubed, D cubed, should I say, D cubed, the negative A squared, and a B, negative B squared. All right, finally, we want to get rid of the square from the C. And since I'm running out of room, I'm going to, I might have enough room. Let's rewrite C squared equals D cubed minus A squared minus B squared. And to remove the square from the C, we're going to use a square root. What you do to one side, you do to the other. And since all these A, B, C, D terms are positive, we won't need the plus or minus because we'll only be using the positive or the plus. So this will finally be C equals the square root, it's a bad looking root, D to the third power minus A squared minus B squared. And that is it.